Welcome to Developer Ramp Up, a channel dedicated to anybody who wishes to become a software developer or a better software developer. In this video we will talk about value types and reference types in .NET. In .NET and therefore in C#, there are two main sorts of type, reference types and value types. Understanding these sorts of type is crucial in the .NET ecosystem and more generally in object-oriented programming, I would say. There are some clear definitions of these concepts that anybody could learn fairly easy, but really understanding how reference types and value types work is sometimes a little bit trickier. And I must confess that it took me some time to achieve a certain level of familiarity. Furthermore, if you really want to understand how reference types and value types work, you need to get your hands dirty and play around with them, of course. In this video, I will try to explain reference types and value types as good as I can, starting of course from some dry definitions, but important ones, that I will try to make more vivid using graphics and different code samples. So let's start looking into reference types. A reference type is a type which has its value a reference to the appropriate data rather than the data itself. And classes, interfaces, delegates, and arrays are all a reference type. But let's check a little bit what does this really mean. And let's for instance try to run this line of code. What happens here is fairly easy. So we declare a new variable which is R&D, and this variable is of type random. And we know random is a class. And then of course we create a new instance of this random class. So we have a new random object, let's say. However, important to note is what will be the value of R&D itself. And here we have also to think a bit about memory. And usually when we talk about reference types and value types, we also think about heap and stack and so on. But for now, I don't want you to focus on heap and stack at all. So just let's think about memory as another place in the computer's memory. And we will come back to heap and stack a little bit later in this video. What happens is then that when this new random object is created, it is sent to a certain location in memory, let's say. And now basically this object, this new random object, is in memory. And we see that the address of the memory block, just for an example, is 011001. And important to note here is that the value of R&D itself is 01101. So the exact value of the memory address where the R&D or the random object resides. So once again, it's important the value of R&D will be the reference to the location in memory where this random object resides. Now, when we want to perform an action on R&D, what happens is that it will look up the reference and then the action itself, it will be performed on the object that is, of course, in another memory location than the R&D variable itself. Now, what happens, for instance, if we create a new variable R&D2, once again of type random, and we make it equal to R&D. What happens here is in fact that R&D2 will be equal to the exact same R&D or random object that we created earlier. However, it's important to note that R&D2 will have as value also the memory location where the object resides. Because remember, the value of R&D is 011001, and the value of R&D2 will be the exact same memory location. So that's why when we want to perform an action from the R&D2 variable, which is an object of the random class, the action will be done or performed on the object itself, which resides in a different location in memory. So this means that if we perform an action on R&D2, basically the object in memory is changed. If we then look up this object with R&D2, we will also see the changes that were made through R&D, because R&D2 is also a reference to the object in memory. So let's also look at this in code, and for doing that we will switch a little bit the class and we will use a Stringbuilder class. So we'll create a new instance of the Stringbuilder class. So it's Stringbuilder, and we'll name this SB, and this will be equal to a new instance of Stringbuilder. And remember the graphics. What it happens here is that the object that we create, so the new instance of Stringbuilder, does not reside or is not assigned to SB, but it is somewhere in memory, and SB has at its value the reference to the memory location where the Stringbuilder resides. Now let's append something to the Stringbuilder, and we'll use the append method, and let's append hello. Sorry for the typos. Okay, that should be good. Now let's create a new variable also of type Stringbuilder, and this will be called sb2, and let's make sb2 equal to sb1. So remember once again the graphics. What it happens here is that sb2 gets the reference that sb1 has, so it points to the exact same Stringbuilder object in memory. Now let's try to append here also something, and we will append world. Okay, and now let's print this to the console. So console write line, and let's print first SB, so the first variable that we declared, and also let's print SB2, which is the second variable, and where we appended this world string. And also let's add a console.readline to make sure that the console will remain open when we run the program. And right now, if you run the program, let's guess what we will see. And we can see both times we print hello world. Why does this happen? It's very easy, as we said, because both SB and SB2 refer or have as value a reference to the exact same Stringbuilder object. So what it happened when we appended here hello, it got appended to the Stringbuilder object that resides somewhere in memory. Now when we declared SB2, we assigned to it the reference to the memory location where the Stringbuilder object resides. So that's why when we performed this append of world, it appended it to the same Stringbuilder object, so it appended it to the already existing hello. And that's why no matter if we print SB or SB2 to the console, we will always get the string hello world. So this is how reference types work. Let's now look into value types. While reference type contain a reference to the object itself, variables of a value type directly contain the data. Assignment of a value type involves the actual data being copied. And simple types such as float, int, char, then enums and structs are all value types. Let's look how value types work. Now let's think that we create a new variable which is number of type integer. Now integer in C# in .NET is a struct, so it is a value type. Now we created a number and we assigned it the value 5. Previously, when we talked about reference types, we also talked about a different memory location and we had a certain memory address. And remember that the reference type or the variable of a reference type contained as value let's say the memory address of the place where the object resides. However, if we think about integers, which are value types, this doesn't happen. So the 5 is not sent to that memory location. Instead, the number 5 or the variable number equals 5, not 011001. If we create a second value type or a second variable number 2 of type integer and we assign it the number, what it will happen, it will assign to number 2 the value of number. So it will be 5, not 011001. And therefore number and number 2 are totally independent. If we change the value of one variable, the other won't be altered at all. So this is how value types work. Now, as a next step, let's also look into a little bit of code and see exactly how we can declare a struct and how we can perform the exact same actions that we performed previously on a reference type, which was a Stringbuilder, and the difference in the output that we will get printed to the console. Let's first create our own struct, and to do that we will declare a new struct. We'll call it int container, and we have to declare it, and let's give it a property. It will be int e, and let's make it public int I. Okay, and now we declare the struct. So that's basically it. It's not a big deal. Now let's create a new instance of this struct. It will be int container. Let's name it first equals new int container, and that's it. Okay, I missed the brackets. Oh, this should work. Good. Let's now, for example, first.I, let's make it equal to 5. Now let's create a new variable which we will call second, and it will also be an instance of the int container. So it will be int container second equals, and this will be equal to first. So exactly the same thing that we performed also in the case of the Stringbuilder. Now if we go second.I, and we will make this be 10. So that's it. Now let's print this to the console, and let's print for first, and also we have to print first.I. Okay, this would be it, and console write line and second.I. Now guess what we will get printed to the console? Will it be 5 and 10, or will it be 10 and 10? Let's check it out. So now we try to run this program, and okay, it closed the console window. What we have to do, I usually always do this, is add a console readline at the end to make sure that the console window will stay open even after the output is displayed. Now let's run the program once again, and in this case we'll see 5 and 10. And remember what I told previously, in case of value types, even if we declare first equals second, they will still be totally independent, and when we make a change of on one of the variables, the change will affect only the specific variable, not the other. And we saw in case of reference types, this was a little bit different. But in order to make it clearer and to see exactly how value types and reference types behave, I want to make a head-to-head comparison. So in order to do that, let's create also a class, which will be, okay, class, we will name it int container, okay, container class. And what we will declare in this class is a public int I and get set, a property, a public property in the class, which is named also I, like it was also in the case of the struct, so that we have really similar, or I would say almost equal data structures, the only difference being that int container is a struct and int container class is a class. Now we already have the information that we already did here, and I just want to build on this, and let's also create a new variable of type int container class, and it would be int container class. Let's name it first class, and it will be equal to a new int container class. Okay, so remember, this is a class, so it's a reference type. So first class, what we'll get is basically a reference to the memory location where the new int container instance is located. And we first class dot I equals, let's put also 5. So that's it. We declare the I. Now let's go one step further and create a new variable, also of type inContainer class, and we will name it second class, and it will be equal to first class. So what will happen here is that the variable second class, as we explained, will contain as value the reference to the memory location where the inContainer class object is located. And let's do also second class dot I equals and make it 10, just like we did it also for the struct. Now let's go here and let's print to the console. We print first class dot I first, and then we print second class dot I in second place. And this is the big moment to see exactly the difference between value types and reference types. If we run this program right now, what we will see as output is when we performed the action on the struct, we got 5 and 10 because value types are totally independent. But when we performed exactly the same actions on a class object, then you see we got 10, because what we get here is basically a reference. So when we add something to the object here, the second time, basically this 5 will be deleted and it will be replaced by 10. So that's why no matter if we print out the first class or the second class, we will get the exact same value. So this is really the main difference in behavior between value types and reference types. If you enjoyed this video about value types and reference types, don't be shy and please hit the subscribe button so that you would be always up to date when new videos are uploaded to Developer Ramp Up. Also, if you think that you have some friends that might be interested in this topic, also don't be shy and share this video on your social networks. Thank you very much for watching this video, and until the next time, I wish you the very best.